Hello everyone. This experiment is about the slippering machine, and the first one we are doing is the slippering machine with unconnected rotor winding. So we are using the similar board as we were using before for the synchronous. So the board is the same, but it's only the rotor which is changed. The rotor is a slippering rotor. For the first experiment, we are not connecting the K, L, and M on the top of the rotor. Those are the three-phase supply. So I'm going to click on the power to set the power for 11 volt and 50 hertz to the rotor. But of course, because there is no connection, we do not expect to see any rotation. I am touching the rotor and I can see the rotor is shaking and humming, but it's not rotating. The next experiment is shorted rotor winding. So I'm going to use 3 jumpers. So 3 jumpers to connect K and L and M to short them. And if I apply the power to the rotor, you can see that the rotor started rotating. Next experiment is voltage for an unconnected rotor winding. So we're not going to connect the rotor to the power, and we only going to provide the power supply for the stator. So I'm going to connect the power supply. You can see that the voltage on the rotor is measured, and also the voltage on the stator. So in this case, first of all, I'm going to stop it so you can do the measurements. 5 volt for channel A, 10 volt for channel B. So the blocks are worth, the vertical blocks for channel A is 5 volt, for channel B is 10 volt, and the time division is 5 millisecond. So you can use these numbers to do the measurements. Now I'm going to run it again. At this point, I'm going to change the rotor manually. I'm going to rotate it, and you see that the graphs are changing. So I'll keep rotating the rotor manually, and you can see what happens to the graphs. Next experiment is rotor winding with the starting resistor. In this experiment, you're gonna measure the slip using the graph on the oscilloscope. You measure the frequency, and then from there you can measure the slip. The rotor is connected to a couple of starting resistors, and then the voltage for the stator and the voltage for the rotor is gonna be measured through channel A and channel B. So we are setting the oscilloscope to 1 volt on channel A and 10 volt on channel B, and the time division is 5 millisecond. The voltage is 11 volt, 50 hertz. So I'm gonna start rotating the motor, and you can see that the graphs for voltage and the stator voltage and the rotor voltage are populated on the oscilloscope. So I'm gonna stop the graph so you can do the measurements based on the time scale and the like voltage scale. You can measure the frequency from the graphs. Look at the time division is 5 milliseconds, so each horizontal block is 5 milliseconds. From there you can count the number of blocks and calculate the frequency of F1, which is for the stator, and F2, which is for the rotor, and then follow the formulas on the lab manual. At this point, I'm going to measure the voltage. So I put a line on the rotor, and I'm going to turn on the stroboscope. I hope you guys can see it. Hopefully. Gonna maybe getting it closer. So I increase the RPM. At this RPM, the line almost stopped. It shows like the 510 RPM. is the measured speed of the rotor. So I'm going to stop the motor, and you can answer the question based on the formulas and graphs and the speed measurement. Next experiment is measurements on a stator and rotor. So for this experiment we have the same setup as the previous experiment. The only difference that here we are powering the rotor through a three-phase startup control menu. So in this menu the voltage is going to be 11 volt. So we're going to set the voltage to 11 volt, 50 hertz, and there are two relay timings here for the resistor. So you can see on the board there are two sets of resistor, one set on the top and one set on the bottom, and this relay control menu allows you to set up the timing on removing the resistors one by one from the circuit or adding them to the circuit. So the first delta T is set to 0.2 second, and the other one also set to 0.2 second. This means that after 0.2 second, the first set of resistors are going to be changed, and then after another 0.2 second, the second set of resistors is going to be changed in the rotor circuit. So you can hear the clicking probably after I click on the start button. So this oscilloscope is set to capture the signal, and you can pay attention that you can hear two clicks. One click is because of delta T1, one click is delta T2. You can see the rotor voltage is decreased in two steps. So before the first relay clicks, you have this much voltage on the rotor. When the first relay clicks after 0.2 second, the voltage is going to be decreased on the rotor, and when the second relay again after 0.2 second is changing the resistor on the rotor, the voltage is decreasing for one more step. So that's it for all the experiments related to the Slippering machine. I hope this video was helpful for you guys to do this lab. Thank you for watching it.